Hello, children. Welcome back to my class. So, today I want to ask one question. Have you ever wondered how some numbers are divided so easily and some numbers don't? So, this we are going to see in our chapter Playing with Numbers. So, the first part of this topic is factors. So, first we need to understand what are factors. Okay, so the factors are the number which divides the number exactly and without giving any remainder. Okay, so the factors are the number which divides the number exactly. Exactly means there will be no remainder. Suppose I'm giving you example 18 divided by 9. 18 divided by 9 is 2. So when we are dividing 18 by 9, our quotient is our quotient is 2, but our remainder is here. Quotient is 2, but our remainder is 0. So can we say that 9 is a factor of 18? Understood, children? What happens when you divide any number? Okay, and that number divides the given number exactly without leaving any remainder, that is called factor of the given number. Let me give you one more example. Suppose 12. Okay, 12 is our number. Now let's check. If we divide 12 by 2, what do we get? 6. If we divide 12 by 3, what do we get? 4. If we divide 12 by 4, we will get 3. If we divide 12 by 5, is it possible, children? Can we divide 12 by 5? No, it's not possible. Why? Because here we will not get remainder as 0. Okay, when you will divide 12 by 5, what will happen? 5 times 2 is 10 and your remainder will be 2. So for factors, what is required? Your remainder should be 0. Okay. So in this case, 12 divided by 2, 6 we are getting. Okay. As a quotient and remainder is 0. Same way, 12 divided by 3, 4 we are getting. 12 divided by 4, 3 we are getting. So here we will divide 12 by 6. Okay. Now is it possible to divide further? 12 divided by 7, not possible because 12 doesn't come in 7's table. 12 divided by 8, not possible. Why? Because 12 doesn't come in 8's table, 9's table, 10's table, 11's table, and 12 is only divisible by itself. So can we say the factors of 12 are factors of 12 are 1, 2, 3, 4, 6, and the number itself, 12 itself. Okay, so what are the factors of 12? 1, 2, 3, 4, 6, 12. And why these are called as factors? Because this divides 12 exactly without leaving any remainder. So factors concept is clear, children. One more thing which you need to keep it in your mind for factors, that there are minimum 2 factors for each number, even if the given number is odd. Okay, so the minimum 2 numbers will be 1 and the number itself. Okay, because there are certain numbers, there are some numbers which has no factors. Okay, I'm giving you example of 7. Here, 7 is not divisible by any other number. Okay, 7 is an odd number. Usually it is an odd number only. Okay, but there are some odd numbers also which has a factor, more than 2 factors. So 7 has only 2 factors, 1 and the number itself, that is 7. Okay, so factors of 7 are 1 and 7. Same way we can say example of 11. Here, factors of 11 are also 2, 1 and 11. Factors of 13 also 2, 1 and 13. So minimum in for every number you will get 2 factors. So that is minimum. Maximum, that depends on the number. Okay, I'm giving you one more example of 15. 15 is an odd number, but 15 is divisible by 1. 15 is divisible by 3, 15 is divisible by 5, and 15 is divisible by the number itself, that is 15 only. Okay, so the factors of 15 are 1, 3, 5, and 15. Okay, so the what are factors, children? What are factors? Factors are the number that divides a given number exactly without leaving remainder. I hope the concept of factor is clear to everyone. So we are done with part 1, factors. Now let's start with multiples. What are multiples that we are going to see? Now children, after factors, we need to see multiples. So what are multiples that we need to understand? So what are multiples? Multiples are the product of factors. Okay, what are multiples? Product of factors. Okay, so let's say example as 8. So what are the multiples of 8? 8, 16, 24, 32, 40, and so on. So basically we can say what are multiples? Multiples are simply tables. So if I ask you what are the multiples of 12? So multiples of 12 are 12, 24, 36, 48, okay, and so on. What is the first three multiple of 6 if I ask? 6, 12, and 18. So what are multiples? In short, we can say tables. Okay, simple. If somebody asks you, what are first three multiples of 9? So 9, 18, and 27. Why? Because 9 times 1 is 9, 9 twos are 18, and 9 threes are 27. So first three multiples of 9 are 9, 18, and 27. Okay, if I ask first 5 multiples of 16. So 16, 32, 48, 64, and 80. Why? Because 16 times 1 is 16, 16 times 2 is 32, 16 times 3 is 48, 16 times 4 is 64, and 16 times 5 is 80. So here what I'm doing, children? What I'm doing? I'm simply writing table of the given number. Okay, so in this way it's very easy to calculate multiple of any number. What we need to do? We need to do simple multiplication. Okay, from each factor. So 16 times 1, then 16 times 2, then 16 times 3, and so on. So this is all about multiples. Now children, after factors and multiples, we are going to start prime numbers and composite number. And this chapter also children we had revised in our previous classes. But then again I'm going to explain you what are prime numbers and what are composite numbers. So what are prime numbers? Prime numbers are the numbers which have only two factors. Okay, prime numbers are the numbers which have only two factors. That is 1 and the number itself. Okay. Example we can take prime numbers. It has only two factors, number 1 and the number itself. 1 and the number itself. Okay, children. Example we can say 3. Do we have any factors of 3, children? No, because 3 is not divisible by any number except 3. So what are the factors of 3? 1 and 3. Factors of 5, 1 and 5. Factors of 7, 1 and 7. Factors of 11, 1 and 11. Factors of 13, 1 and 13. So these are all prime numbers, children. 1, 3, 5, 7, 11, 13. Okay, now there is a, have you observed that all the numbers here are odd numbers? So can we say all odd numbers are prime numbers? Can we say? No, we cannot say because there is an exception. All odd numbers are prime numbers except 2. And 2 is the smallest prime number. We all know, children, 2 is a even number, right? But 2 also have only two factors, 1 and the number itself, that is 2. So 1 and 2 are the factors of 2. So 2 is an exception here. So what are the prime numbers? Numbers which have only two factors. Okay, two factors means that the number given is divisible by only the given number or 1, right? If we take example of 23, 23 is an odd number, and you can check in your mind that 23 doesn't come in any of the table. So 23 is not divisible by any of the number except 23 and 1. So how many factors we have for 23? 1 and 23. So these are all prime numbers. Okay, and 2 is the exception. 2 is the smallest prime number. Now, what about 1? Can we consider 1 as a unique number? Do we have two factors of 1? No, we cannot consider 1 as a prime number. So, can we consider 1 as a composite number? No, we cannot consider 1 as a composite number also. So, what is 1? 1 is a unique number. Children, keep this in your mind. 1 is a unique number. So prime numbers are the numbers which have only two factors, 1 and the number itself, and 1 is a unique number. And these are the examples of prime number. Okay, children. Now, what is there in composite number that we are going to see? First, we will understand what are composite numbers. Composite numbers are the numbers which have more than two factors. Okay, apart from 1 and the number itself, there are more factors, and that depends on the number. There can be 3 factors, 4 factors, 5 factors. Okay, so which has more than two factors, they are called as composite number. And composite numbers are usually even, but we cannot say all even numbers are composite number. Even and odd, it's a combination. Because let's take example of 15. 15 is here odd number. But if you will see, the factors of 15 are more than 2. So 15 is not a prime number, though it is an odd number, but it is not a prime number. Let's think 15. 15 is divisible by 1. Okay, 15 is divisible by 3. 15 is divisible by 5. And 15 is divisible by the number itself, that is 15. So how many factors we have for 15? 4. So 15 is a 15 is a composite number. So children, 15 is divisible by 1. 15 is divisible by 3. 15 is divisible by 5. And 15 is divisible by 15 also. So how many factors we have for 15? 4 factors, which is more than 2. That means 15 comes in the category of composite number, not prime number, though 15 is a odd number, but then also it is a composite number, not prime number. Now let's see what are composite numbers and example of composite number. Now children, after prime numbers, we will see composite number. Now what is composite number? Which has more than two factors. I had already given you example of 15. Let me give you more example, like example of 9. Okay, so what are the factors of 9? 1, 3 and 9. 12. 1, 2, 3, 4, 6 and 12. So how many factors are there we have for 12? 1, 2, 3, 4, 5, 6. So we have 6 factors of 12. Why children? Because 12 is divisible by 1, 12 is divisible by 2, divisible by 3, divisible by 4, divisible by 6 and divisible by 12. So what we need to check? We need to check divisibility also. Okay, we need to see here if the given number is divisible by more than two numbers, that means it has more than two factors. That means it is a composite number. Okay, so this is all about composite number which has more than two factors. One we have already understood. What is one? One is a unique number. What is prime number? Prime number means which has only two factors, one and the number itself. Okay, mostly it is odd number except 2. 2 is the exception. 2 is a smallest prime number. 2 is a even number, but then also it is a prime number. Okay, so the concept of prime and composite is clear to everyone. Now I'm going to explain you what are co-prime numbers. Okay, we will see what are co-prime numbers. Now children, after prime and composite number, what we are going to see? We are going to see co-prime numbers. Now what are co-prime numbers? So two numbers are said to be co-prime if their HCF is 1. So what is the condition children? That the two numbers whose HCF is 1. What is HCF? Highest common factor. So their highest common factor should be 1. Okay, if it is coming as 1, then it is considered as co-prime numbers. Okay, and there is one more condition. They need not to be prime numbers. It's not compulsory. One can be composite, one can be prime, or both the numbers are prime. But it's not compulsory to have both the numbers as prime numbers. Okay, but what is important, children, here? What is mandatory? That their SCF should be 1. Now I'm giving you example. Example 3 and 4. What is the highest common factor between 3 and 4? 1, right? So their SCF is 1. So can be considered as co-prime. So can we say 3 and 4 are co-prime? Yes, we can say 11 and 13. 11 and 13. Here both the numbers are prime numbers. Okay. And their SCF is 1. So can we say 11 and 13 as co-prime numbers? Yes, children, we can say. Here you can see 3 is prime and 4 is composite. So what I have written here, they need not to be a prime numbers. So it's not compulsory to take both the numbers as prime numbers or both the numbers as composite number. One can be prime, one can be composite, or both the numbers can be prime. Okay. I'm giving you one more example. Uh, let's say 7 and 8. 7 and 8 also, there is no common factor between 7 and 8. So we can say 1 as a common factor. So highest common factor will be also 1. So we can say 7 and 8 also as a co-prime number. So the concept of co-prime number is clear to everyone. Okay. What is the thing that for co-prime numbers, two numbers are said to be co-prime if their highest common factor is 1. Okay, their highest common factor should be 1. Okay, and you can take any combination. One can be prime, one can be composite, and both can be prime. Both can't be composite. What will happen if both the numbers are composite? You will not get highest common factor as 1. Okay, now I have one more thing, that is twin prime numbers. After co-prime numbers, I will make you understand twin prime numbers. Now what are twin prime numbers? That we are going to discuss. Now children, after co-prime numbers, we are going to see twin prime numbers. Okay, what are twin prime numbers? Now here it's clearly written two prime numbers with a difference of 2 are called as twin prime numbers. Okay, so it's clearly written that we need to take two prime numbers only. Here we cannot take combination. One prime number, one composite number, or both the numbers. Both the numbers should be prime only. For this twin prime numbers, then only you'll be able to find twin prime numbers. Okay. So what is the condition? Two prime numbers with a difference of 2. Okay. I'm giving you example 11 and 13. Okay. 11 is a prime number, 13 is a prime number. Now let's see the difference. 13 minus 11 is 2. So can we say 11 and 13 as twin prime number? Can we consider it 11 and 13 as twin prime number? Yes. So 11 and 13 are twin prime numbers. Now I'm giving you one more example, 5 and 7. Here 5 is prime number, 7 is also prime number. Now difference of 7 and 5 is 2. So 5 and 7 are also twin prime number. Okay. Now if I say 13 and 17. 13 is a prime number. 17 is also a prime number. Difference of 13 and 17 is 4. Okay. Difference of 13 and 17 is 4. So can we consider 13 and 17 as a twin prime number? No. We cannot consider because the difference is more than 2. So 13 and 17 though both are prime number, but we cannot consider them as a twin prime number. Okay, children? Understood? Now I'm giving you one more example. If I take example of 7 and 9. 7 and 9. Can we take 7 and 9 as a twin prime number? We cannot take. Why? Here 7 is a prime number, but what is 9? 9 is a composite number. So we need both the numbers as prime numbers only. So the definition is clear. The concept is clear, children. What is the condition? That the two prime numbers where their difference should be 2. Okay, the difference of two prime numbers should be 2. Then only it is called as twin prime numbers. If the difference is more than 2 or less than 2, or if any of the number is a composite number, then they cannot considered as twin prime numbers. Okay, children? Now, children, we will see prime factorization. Now, what is prime factorization? We all know what are prime numbers, what are factors. Okay. What are prime numbers? Prime numbers are the number which have only two factors, that is 1 and the number itself. And factors also I have already explained you. So what is prime factorization here? Prime factorization means expressing a number as a product of prime numbers. So here we are going to break a number in such a way that we'll get all the numbers as prime numbers. Okay, for that we will use two methods. So the first method will be your factor tree method. This is very interesting method. One of my favorite method. So this is factor tree method, and another method is common division method. Common division method. So children, we are going to see one by one prime factorization using factor tree method and prime factorization using common division method. So first we will start with factor tree method. Now children, we will see, we'll start with factor tree method. This is very, very easy method. Okay, and very interesting method. So we'll start with any number. Let's say example 36. Now, factor tree means what, children? We are going to make a tree. We are going to divide this 36 into parts where we will get each number as prime numbers. Okay. So, 36, meaning we will always start with the smallest prime number. And which is our smallest prime number, children? 2. 2 is our smallest prime number. So we need to check 36. 36 your number. So we need to check whether this 36 is divisible by 2 or not. That we need to see. So 36, yes, it is divisible by 2. So 2 times 18. 2 times 18 is 36. So here we have prime number as 2. But 18. 18 is a prime or a composite number? It's a composite number. So again, we will factorize this 18. 2 multiplied by 9. So here 2 is again our prime number and 9 is a composite number. Why? Because it has more than 2 factors. Fine. What are the factors of 9? 1, 3, 9. More than 2. Right? So that means 9 is a composite number. Again, we will divide 9. Now children, 9 is an odd number which is not divisible by 2. So we will divide here by 3. 3 multiplied by 3. Now this 3 is also your prime number. This 3 is also prime number. So now is factorization possible, children? No. Now we cannot do factorization further. We have already got all prime numbers. So the prime factors of 36 are this 2 we will take. We will not take composite children, no, composite number children, okay? So this 2 we will take, this 3 and 3. So what we are going to consider? All prime numbers only. So 2 multiplied by 2 multiplied by 3 multiplied by 3. Now, after multiplication, we need to check whether we are getting this 36 or not. Let's see. 2 times 2 is 4. 4 times 3, 12. 12 times 3, 36. That means these are the prime factors of 36. Okay, and this method is called as prime factorization using factor tree method. Okay, now I'm going to give you one more example using 3-digit number. Now, children, our next example is 180. Okay, suppose this is your number and we are going to do prime factorization of this number using factor tree method. Again, we'll have to draw factor tree. Okay, so 180 is an even number which is divisible by 2. So again, we'll start with the smallest prime number, that is 2. Okay, so I will write here 2 multiplied by 2 nines are 18. 0 will come as it is. 2 times 90 is 180. Again, 90 is a even number which is divisible by 2. Again, we will divide by 2. 2 multiplied by 45. Children, for this, if you want to draw working column, you can draw working column and you can see 90 divided by 2 what you are getting. That also you can do. If verbal, if in your mind only if you are able to do, that is very good. Okay, so 2 multiplied by 45 is 90. Now 45 is an odd number which is not divisible by 2. So what we will do? Another number which factor we will take? 3. So 45 divided by 3 when we will do, what we will get? 15. Very good. Now 15, what we will see? 15 is again odd number. Again we will take 3 multiplied by 5. Now here 3 is a prime number. 5 is also a prime number. So no more factorization is possible now. We cannot do more factorization. So we will write directly prime factors. So 2 is prime number, 2 is prime number, 3, 3 and 5. So we'll write 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. Okay, now we will start calculation. 2 times 2, 4, 4 times 3, 12, 12 times 3, 36 and 36 times 5 is 180. That means your factor tree is absolutely correct. Okay, and these are your prime factors. Understood, children? Can we start common division method now? Now, children, for common division method, we need to do division. Okay, suppose let's say example as 45. This is your number. We need to do prime factorization of 45 using common division method. Okay, so here we are not going to make any tree. We will do directly division. So we need to see whether the given number is divisible by the smallest prime number. No, it's not possible here, children. Why? Because 45 is a odd number which is not divisible by 2. So we'll start with 3. So 3 times 15 is 45. Again, 3 times 5 is 15. Okay, if you want to write here 5 times 1, you can write. So what are the factors of 45? 3 multiplied by 3 multiplied by 5. You can check. 3 times 3 is 9 and 9 times 5 is 45. We can take another example like 120. Now this is your even number. Can we directly start by 4? We can do that. Can we do? Is it possible to divide 120 directly? We know that 120 is divisible by 4. Can I directly divide by 4? Can I directly divide by 6? Can I directly divide by 12? No. Because what we are doing here, what we are doing, children, we are doing prime factorization. So prime factorization means we want product of prime numbers. Fine. So 120 is a even number which is divisible by the smallest prime number, that is 2. So we'll start by 2. Now 2 6 are 12, 0 will come as it is. 2 multiplied by 60 is 120, right? Again 60 will be divided by 2, so we will get 30. Again 30 will be divided by 2, we will get 15. Now this 15 is our odd number which is not divisible by the smallest prime number. So we will take next number, that is 3. 3 times 5 is 15. So what are the factors of 120? If you want to write here 5 times 1, you can do. 2 times 2 times, so 3 times 2 we will write. 1 time 3 and 1 time 5. Let's see whether we are getting 120 or not. 2 twos are 4, 4 twos are 8, 8 times 3 is 24 and 24 times 5 is 120. So 120, 120 we are getting, that means our method is correct. Okay, there is no error in this method. Okay, so this common division method and factor tree method is clear to everyone, children. So I'm closing this chapter here, though we have not completed the chapter. Second part I'm going to show you in my next lecture, that is HCF and LCM. Okay, in HCF also we are going to see two methods. In LCM also we are going to see two methods. So what all things we have covered till now, children? What we have covered? First, factors we have done, multiples done, prime numbers, composite numbers, what are co-primes, twin primes, and prime factorization, which includes two methods, that is factor tree method and common division method. So this much we have seen in my this lecture. In my next lecture, we are going to see highest common factor and lowest common multiple. And there are two methods for each that we will see in my next lecture. Thank you, children.